A Rolls-Royce can cost several $100,000 and take more than 600 hours to build. Yet when one finally looks finished, Goodwood drives it into a chamber and blasts it with water. One leak, one rattle, or one wrong frequency can send it back. Because here, looking perfect proves nothing. And the strangest failure came when engineers made a ghost so quiet that the silence itself became a problem. Failure reveals what Rolls-Royce is really manufacturing. Not simply leather, metal, wood, and paint, but the absence of unwanted sensations. No vibration through the seat, no whistle around a windowsill, no visible break in the grain of a wooden panel, no hesitation when more than 2 tons of car begins to move. The factory must control thousands of tiny variables so completely that the owner never has to notice them. And that process begins long before anyone touches the car. At Goodwood in West Sussex, every modern Rolls-Royce starts as a commission. The client chooses a model, but that only establishes the outer boundary of the project. Paint, leather, stitching, embroidery, veneers, metal finishes, lighting, and artwork can all be developed around an individual idea. Rolls-Royce maintains a palette of roughly 44,000 paint colors. If the right color does not exist, the Bespoke team can create another, sometimes using an object supplied by the client as the reference. Object might be a piece of fabric, a personal accessory, or a carefully selected sample from somewhere else in the owner's life. The challenge is not merely copying how it looks under one showroom lamp. The color has to work across an entire curved body, under daylight, artificial light, shadow, and reflection. This changes the first assumption about how the car is made. Production does not begin with a standard vehicle that is customized near the end. It begins with a specification detailed enough to govern thousands of decisions throughout the build. That idea has deep roots in the company's history. When Charles Rolls met Henry Royce in 1904, an automobile could be sold as a rolling chassis and then clothed by a separate coach builder. The engineering and the visible body were connected, but they were not always created by the same organization. Modern Rolls-Royce operates very differently. Yet the old coach-building instinct survives. The mechanical foundation should be reliable, while the visible car can be shaped around its owner. At Goodwood, however, there is no single artisan building one automobile from beginning to end. Different parts of many commissions move through specialized departments at the same time. Woodworkers may be matching veneer for one car, while trimmers fit leather for another, and technicians assemble the chassis of a third. The craftsmanship is personal. The production system is carefully coordinated. Beneath the finished surfaces is Rolls-Royce's aluminum spaceframe architecture. It provides the structural foundation for vehicles with very different proportions and purposes, from a phantom limousine to a Cullinan SUV or the electric Spectre. The frame must be rigid enough to support the body and suspension without introducing unwanted movement, yet adaptable enough to accommodate different dimensions, drivetrains, and bespoke requirements. This is where the famous magic carpet sensation begins. A soft seat cannot create it by itself. The structure, suspension, steering, tires, powertrain, and cabin must react as one system. If the body flexes unexpectedly, seals can move and trim can creak. If a suspension mounting transmits the wrong frequency, the passenger may feel it through the floor. If a wheel and tire generate too much road noise, layers of leather cannot hide it. Luxury begins with forces the customer will never see. While the structure takes shape, the exterior begins its own transformation. Inside the exterior surface center, robots apply paint because a machine can maintain an extremely consistent spray pattern across a large and complex surface. Depending on the finish, a Rolls-Royce can receive as many as 20 individual layers. Those layers are not simply repetitions of the same color. Primers prepare and protect the surface. Color coats establish the tone. Clear layers add depth and protection. Special effects may require additional material and additional work. Automation gives the finish uniformity. It does not declare the surface complete. After painting, people inspect and polish the body. Light reflected across the panel exposes defects that may be almost impossible to see when looking directly at the paint. A slight distortion in that reflection can reveal dust, texture, or an uneven transition. Standard polishing alone can require around 4 hours. More complex finishes demand more. This is the pattern that repeats throughout Goodwood. Machines deliver repeatability, and human beings judge whether the result feels right. A sensor can measure paint thickness. A skilled inspector can notice that 2 panels do not appear to belong together under the same light. A computer can reproduce a line perfectly. A person can decide whether that line belongs on this particular car. The clearest example is the coach line, a narrow painted line running along the side of the body. On current Phantom, Ghost, and Cullinan models, it is approximately 3 millimeters wide. On Spectre, it is 4. It is painted freehand by a specialist using a fine natural hairbrush. There is no stencil hiding beneath it. The artisan must guide the line across long panels, door gaps, changing reflections, and the subtle curvature of the body. Once the brush touches the surface, hesitation becomes visible. The line is tiny. That is precisely why it matters. A large decorative feature can dominate the car. The coach line has to follow it. It must look deliberate without demanding attention. And it has to remain visually continuous even when the physical surface beneath it is not. This is no longer just painting. It is a controlled movement performed on a surface that may already represent hundreds of hours of work. Meanwhile, mechanical assemblies are approaching the most dramatic moment on the production line. The body and the prepared drivetrain are brought together in a process manufacturers call the marriage. One assembly is positioned above the other. The two are aligned, lowered, and secured until the car changes from a collection of major systems into one connected machine. It looks fast compared with the work surrounding it. That speed can be misleading. The marriage works only because the difficult decisions have already been made. Mounting points, wiring, cooling connections, suspension components, control systems, and protective clearances all have to arrive in the correct position. Technicians use monitored tools to apply the required torque to critical fasteners. The tool does more than tighten a bolt. It can confirm whether the fastening operation reached its specified value, creating a record that can be checked later. Then come the doors, glazing, electrical connections, dashboard, seats, trim, controls, and the countless smaller pieces that turn the structure into a cabin. But adding more material does not automatically make that cabin more luxurious. Rolls-Royce discovered this while developing the Ghost. Engineers were working toward an exceptionally quiet interior. Around 100 kilograms of acoustic material were incorporated into areas such as the roof, floor, and body structure. The glass, tires, ducts, seat frames, and interior cavities were studied for the sounds they transmitted or produced. The obvious goal appeared to be zero noise. Then test occupants experienced the result. The cabin had become so acoustically isolated that the sensation could feel disorienting. With familiar sound cues removed, the environment did not feel naturally peaceful. It felt wrong. The problem was not that the car remained too loud. It had become quiet in the wrong way. So the engineers did not simply add random noise back into the cabin. They worked to make the remaining sounds compatible. Components were tuned so that one frequency would not suddenly stand out. Damping was added to the seat structures. Ports were used to control the acoustic behavior of large cavities. The target became a subtle, consistent background tone, a whisper rather than a void. That is the central principle behind the entire car. Perfection is not the maximum possible score on one measurement. It is the point at which thousands of measurements stop fighting one another. The same principle governs the leather shop. A hide can be technically usable and still fail the visual standard. Under intense light, specialists examine it for scars, marks, bites, and variations that should not appear in prominent areas. Unsuitable regions are marked. Software then calculates an efficient layout for the required components, and precision cutting equipment turns the digital pattern into physical pieces. Yet the computer's answer is not automatically final. A human operator may change the layout after noticing that a natural feature would sit awkwardly across a seat or interrupt the appearance of a panel. The machine optimizes material use. The craftsperson protects the finished experience. In certain areas, the leather is skived, reduced from roughly 1.5 millimeters to about 0.6 of a millimeter. This thinner edge allows layers to meet without producing bulky seams. Too thick, and the join may become visible or uncomfortable. Too thin, and the material can lose strength. After cutting, pieces are stitched, embroidered where required, and stretched over the underlying forms. Curves must remain smooth. Stitch lines have to follow the seat architecture. The leather must feel soft while remaining secure enough to survive years of movement, heat, cooling, pressure, and contact. Even the sound matters. Two beautifully trimmed surfaces that rub together can create a squeak, and in a cabin this quiet, a small squeak becomes a leading performer. Leather must be made visually consistent. Wood presents the opposite challenge. Its natural variation is the very thing Rolls-Royce wants to preserve. Every piece of veneer contains a record of growth, grain direction, color, figure, and small variations formed over years inside the tree. The factory does not attempt to erase that character. The goal is to control how it travels through the cabin. Visible veneers are selected from the same tree, so their grain and color can be matched, and so they are likely to age together. Craftspeople study the pattern before deciding where individual panels should be cut. With book matching, neighboring sheets are opened like pages, creating reflected patterns. A center console may use a chevron arrangement, with the grain meeting at approximately 55 degrees. Angle sounds like a minor specification until the two halves are placed side by side. If either piece shifts, the pattern loses its balance immediately. Before this work can begin, the veneer must be stabilized. Rolls-Royce has described storing wood for at least 3 days in a controlled humidor at approximately 23 degrees Celsius and 75% humidity. The purpose is not ceremonial. Wood responds to moisture. If it expands or contracts at the wrong time, a panel that looked precise during production may distort later. The finished pieces are therefore exposed to temperature extremes to see whether adhesives, coatings, and veneers continue behaving as one material. If a small natural blemish needs repair, a craftsperson can insert a sliver taken from the same veneer. The grain must align closely enough that the correction disappears into the original pattern. A repair is acceptable only when it stops looking like a repair. That principle explains why the same tree is used across visible areas. Matching the color today is not enough. The panels should also change together years from now. Rolls-Royce is trying to manufacture a surface that remains coherent as a living material continues to age. Some commissions push this work far beyond familiar wood trim. In the Phantom, the dashboard can contain the gallery, a sealed display area where artworks and specially developed pieces can be installed behind glass. Its assembly occurs in a controlled cleanroom environment. Rolls-Royce has described the work as being entrusted to just 2 trained associates. Products that might release particles, including certain cosmetics, hair products, and deodorants, are prohibited. The completed gallery is examined under ultraviolet light, because contamination invisible in normal conditions may become obvious once sealed behind glass. This is a remarkable amount of discipline for an object that most passengers will never touch. But once enclosed, a speck of contamination could remain directly in the owner's line of sight. In another part of the interior, the roof is being turned into a night sky. Starlight Headliner contains hundreds of individually placed fiber optic strands, typically between 800 and 1,600. Each strand is passed through the material and set to the required visible length. A standard design can require around 9 hours. A personalized pattern can take more than 17. The arrangement may represent a familiar constellation, a sky connected with a specific date, or a composition created for the commission. The brightness can vary from point to point, giving the surface depth, rather than making it look like a panel covered in identical lights. It is a poetic feature created through highly repetitive physical work. Place a fiber, set its depth, check the visible end, and repeat hundreds of times. And it cannot be treated as decoration added after engineering is finished. The headliner must still fit. It cannot introduce unwanted sound. Its fibers and electronics must remain protected. The finished roof has to function as part of the same quiet cabin. Bespoke work is allowed to change the car's appearance, but it is not allowed to escape the car's standards. That becomes increasingly difficult as requests grow more complex. Special embroidery may contain hundreds of thousands of stitches. Unusual materials may behave differently under heat, sunlight, or vibration. A design that works as a drawing may distort when it is wrapped around a 3-dimensional surface. The Bespoke team must translate personal ideas into components that can be produced, installed, tested, and maintained. A client can ask for something unprecedented. The factory still has to answer familiar questions. Will it fade? Will it crack? Will it rattle? Will it interfere with another system? And after years of use, will it still look intentional? This is where craft and engineering stop being separate stories. Craft makes the request possible. Engineering keeps the result from becoming fragile. After hundreds of hours of making the car look perfect, the factory now tries to prove that it isn't. Technicians inspect the controls, lighting, displays, doors, windows, seats, climate system, and electrical functions. The car can be operated on a rolling road, so that systems are checked under controlled movement. Different surfaces and suspension inputs help reveal vibrations or noises that remain hidden when the vehicle is stationary. Then comes the water. In a documented version of Goodwood's monsoon test, approximately 5,000 liters of recycled water were directed around the car. Water attacks the roof, glass, doors, seals, and body openings from multiple angles. This is not a gentle simulation of British drizzle. The goal is to expose a weakness before the owner can. A leak may begin far from the place where water finally appears. That makes diagnosis its own investigation. Technicians must identify the entry point, correct the fit or sealing surface, and verify that the repair has solved the actual problem. The beautiful car has become evidence. A drop of water is evidence. A faint vibration is evidence. A reflection that bends unexpectedly across the paint is evidence. And because luxury depends on the disappearance of disturbance, tiny evidence can carry enormous weight. Road testing adds conditions the factory cannot reproduce completely. Real pavement changes texture. Loads shift. Air moves around the mirrors, pillars, and seals. A component that remains silent at one speed may reveal itself at another. The tester is not simply asking whether the car drives. The question is whether every system contributes to the same character. For Rolls-Royce, that character must survive far beyond Goodwood. Spectre's development program covered about 2.5 million kilometers, including temperatures from -40 to +50 degrees Celsius and more than 50,000 collective driving hours. That does not mean every customer car travels millions of kilometers before delivery. It means the design was forced through extreme environments before regular production had to depend on it. Cold affects batteries, seals, lubricants, and materials. Heat challenges electronics, adhesives, cooling, and interior surfaces. Rough roads expose fasteners and structures to repeated loads. Long testing reveals interactions that may never appear in a short laboratory session. More than a century earlier, Rolls-Royce was building its reputation through another endurance campaign. In 1907, the Silver Ghost completed a highly publicized reliability run of nearly 15,000 miles. The event helped establish the idea that refinement meant little without durability. The modern factory uses different materials, instruments, and testing systems, but the promise is recognizable. A quiet car must remain quiet. A matched veneer must remain matched. A carefully sealed cabin must stay dry outside the controlled conditions in which it was assembled. This is why more than 600 hours cannot be understood as one artisan working continuously on one vehicle. The time is distributed across design, coordination, surface preparation, assembly, trimming, finishing, inspection, correction, and verification. Complex commissions can take dramatically longer. The most ambitious projects may develop over several years. Much of that time produces something obvious: a painted line, a stitched monogram, a mirrored veneer, or a field of artificial stars. The rest is spent preventing the owner from noticing anything at all. No water entering the cabin. No grain breaking unexpectedly across the dashboard. No harsh frequency rising above the acoustic background. No vibration suggesting that the structure and suspension are working as separate machines. No visual correction announcing where a craftsperson repaired the material. The visible luxury may attract attention, but the invisible work protects the illusion. Return to the coach line. It is only a few millimeters wide, painted onto a body already covered in carefully controlled layers and polished until light moves cleanly across it. The artisan's hand leaves a visible mark, but the movement required to create it is gone. Return to the monsoon test. The water strikes a car that appears ready for delivery. Yet the factory is still asking it to prove that its beauty is more than a surface, and return to the ghost that became too quiet. It showed that removing every sensation does not create luxury. The result must still feel natural, stable, and alive. That is what the hundreds of hours are buying. Not simply expensive materials, not handwork for its own sake, and not perfection as a collection of maximum numbers. A Rolls-Royce is finished only when its thousands of parts, surfaces, sounds, and movements stop drawing attention to themselves and become one effortless experience. At Goodwood, looking perfect is merely the moment the hardest testing can begin. Which matters more in a Rolls-Royce? The details you can see or the flaws you never notice? Tell us below.